The enthalpy change associated with the formation of 1 mole of a compound from its constituent elements, all substances being in their standard states, that is, at 298 Kelvin and 1 bar pressure, is called the standard molar enthalpy of formation. It is represented as delta FH naught. The subscript F indicates that 1 mole of compound has been formed in its standard state from its elements in their most stable states. For example, when carbon and oxygen in their elemental states react to form 1 mole of carbon dioxide, 393.5 kilojoules of heat is produced. Hence, we can say that the standard enthalpy formation of gaseous carbon dioxide is minus 393.5 kilojoules per mole. However, the reaction of formation of water from its elements does not represent the standard enthalpy of formation of water. This is because the heat, 571.6 kilojoules per mole, is evolved when 2 moles of water are formed from the elements at the standard state. This can be referred as enthalpy of reaction. The standard enthalpy of formation in this case would be minus 571.6 divided by 2. That is, minus 285.8 kilojoules per mole. By convention, the standard enthalpy of formation of all elements is assumed to be 0. We can calculate the heat of reaction under standard conditions from the values of standard heat of formation of various reactants and products. The standard enthalpy of reaction can be calculated as the sum of standard enthalpies of formation of products minus the sum of standard enthalpies of formation of reactants. Let's see how we can apply this formula. Let's say that we have to determine the amount of heat required to decompose calcium carbonate to lime and carbon dioxide, given that all the substances are in their standard state. We can use the formula of standard enthalpy of reaction to determine the enthalpy change of the reaction. Thus, we get enthalpy of reaction equals enthalpy of formation of products, that is, lime and carbon dioxide, minus enthalpy of formation of the reactant, that is calcium carbonate. On substituting the values of standard molar enthalpy of formation of the reactants and products from the table of standard molar enthalpy of formation of substances, we get the amount of heat as plus 178.3 kilojoules per mole. Thus, the plus value of the standard enthalpy of reaction indicates that the decomposition of calcium carbonate is an endothermic reaction. Note that the stoichiometric coefficients for all the compounds in the given equation are 1. Now, let us look into the thermochemical equations. Hess's law states that if a chemical change can be made to take place in 2 or more different ways, whether in one step or more than one step, the amount of total heat change is the same no matter by which method the change is brought about. For example, the enthalpy of an overall reaction A gives rise to B along one route is delta RH. Now, if the same reaction occurs through another route, delta RH1, delta RH2, delta RH3, then we can say that delta RH equals the sum of delta RH1, delta RH2 and delta RH3. Let's understand this through a chemical reaction. When sulfur in its elemental state burns to form sulfur trioxide in one step, the heat evolved during the chemical equation is minus 395.4 kilojoules per mole. Now, let's break down the reaction into 2 steps. In the first step, Sulfur reacts with oxygen to form sulfur dioxide. The heat evolved during the chemical equation is minus 297.5 kilojoules per mole. In the second step, sulfur dioxide reacts with oxygen to form sulfur trioxide. The heat evolved during the chemical equation is minus 97.9 kilojoules per mole. If we add the heat evolved from both steps, we get minus 395.4 kilojoules per mole. Note that the amount of heat evolved through the two steps is the same as the amount of heat evolved in one step, thus proving Hess's law.